And so, good morning, good afternoon, good evening. I'm Marcus Medeiros. I'm from LCT Brazil. In Brazil, we have a very huge country, and we are 1,000 of kilometers away from other researchers that are using LCT. And so this conference is something very interesting and helpful for us because we are getting in touch the different research groups that are working with LCT here in Brazil could meet for the first time and share their research results, their research problems, and the ways that they are using LCT and the way they are building translation devices. And so it's really helpful and really very important for us as a Brazilian community of LCT researchers. So we are really very happy to be here with you. I have here with me two colleagues from Brazil, Professor Eduardo Mortimer and Professor Bruno Ferreira. They had previously recorded their presentations. So I will share with you the first presentation of Professor Bruno Ferreira. They are here with us. And so at the end, if you want to talk, if you want to have some questions, they are here to talk with you. So let me try sharing my screen with you. I think it's okay. So I will mute myself and try. If there's some problem, if you can't hear, please tell me that I try to fix it.
Hello, everyone. My name is Bruno, and I'm from Brazil. It's a pleasure to be here to talk a little bit about what we are doing with legitimation code theory, specifically in the field of science education. This is the name of the university where I work here in Brazil, State University of Southeastern Bahia. And these are the topics to be addressed in my speech. So, firstly, I would like to introduce a bit about my research trajectory that precedes my discovery of LCT. Then, I will talk about the new translation device we developed for the semantic dimension, our main results, what's coming next, and lastly, the challenges and implications of using semantic.
I think I felt my internet is not very good here, but I will share it again and we can continue to hear Professor Bruno.
This is very
Marcus, please reshare with audio.
my speech, and my paths that my research trajectory has taken.
About the high structure
In this research, the schools chosen represented in some way socioeconomic contexts of the Brazilian population, strongly marked by several inequalities. My objective was to understand how these social differences influenced pedagogical practice in the teaching of chemistry. I assumed that knowledge about this influence on teaching could help us train science teachers to rise up the learning of all students, regardless of their social class or background. To study the different pedagogical practices, I relied on the concepts of Basil Bernstein's code theory, specifically the concepts of framing and classification, and on the analysis instruments or translation devices developed by the Portuguese ESSA group. We also adapted and built other analysis instruments appropriate for the research we started to develop from this moment on. This and other research projects that followed the first one gave rise to several papers, most of them published in Portuguese, but some of them are available in English. Here I show some of these articles. The first one, called The Influence of Social Context in the Pedagogical Practice of a Chemistry Teacher. The second one, and the third one as well, about questions in the chemistry classes, a comparative study of pedagogical practice in different social contexts. The epistemic dimension and the approach to questioning in chemistry classes, a comparative study of pedagogical practice in different social contexts. This is the last one we published using Basil Bernstein's code theory. Well, in 2017, I did a postdoctoral internship with Professor Eduardo Mortimer, with whom I'm pleased to share this roundtable, and sought to deep the study of classroom discourse, incorporate concepts from other theoretical frameworks to explore the different dimensions of this discourse, especially its epistemic dimension, that is, the one related to different forms and structures of knowledge. It started from the consideration that the interactional dimension of discourse already had different and good instruments of analysis, such as Mortimer and Scott's communicative approach, for example. Then, that was when I discovered LCT and its semantic dimension. At first, what most caught our attention was the possibility of investigating classroom discourse in its temporal perspective. Let me explain further. The temporal perspective in the study of the semantic dimension in classroom discourse allows us to investigate the variation in time of the forms of knowledge that the discourse communicates. I came to realize that the instruments we used based on the concept of classification provided us with a more static picture of the discourse, whereas the semantic dimension enabled a dynamic picture of the movement of the discourse, more faithful to the nature of this object. According to LCT, the key to providing successful learning experiences lies in making the explanations and activities obey the structure of a semantic wave. By analyzing shifts in semantic density or semantic gravity, it is possible to obtain and conceptualize semantic waves. This is characterized by a subsequent downward shift or weakening and an upward shift or strengthening in the degree of semantic density or gravity, generating in this way a wave form. In the words of Mayton, semantic waves involve the semantic weaving together within practice of different types of knowledge or semantic codes. We then developed two translation devices for the investigation of semantic density and semantic gravity of the chemistry classroom discourse and applied them to the classes of two teachers in a comparative perspective. The first one is the device for the semantic density, and the one below is the device for the semantic gravity. Through the analysis employing the translation devices, it was possible to obtain semantic waves from the classes, and through the contrast between these two different profiles, it was possible to observe the different ways of organizing scientific knowledge developed by the two teachers. So the first one is a profile, semantic waves from the class of one teacher, and the second one is the semantic waves from the second teacher. We can compare, they are very different between each other. That initial story was published in 2019 in Portuguese. In the same year, I participated in the LCT4 conference in Johannesburg, when I had the opportunity to present a paper entitled "The Application of the Wording Tool in the Analysis of Semantic Density Shifts in Chemistry Teaching." From my participation in the third LCT conference, I was invited to write a chapter for a collection that will be published this year on science education and LCT. Our chapter, in partnership with Professors Eduardo Mortimer and Ademir Silva Jr., is entitled "Using Variation in Classroom Discourse, Make Chemistry More Accessible." In this chapter, we present a new translation device for the analysis of the epistemic semantic dimension of classroom discourse for chemistry teaching, based on the notion of lexical density. So here we can see the translation devices we developed. We also compare and discuss the use of this device with the previously developed device, and apply both to fragments of the discourse of 4 chemistry teachers in order to explore the limits and possibilities of these two devices for the analysis of epistemic semantic density. Here is an example of the application of this translation device to the analysis of classroom discourse in chemistry teaching based on the notion of lexical density for the study of epistemic semantic density. It is important to note that the translation devices we constructed for the semantic density analysis relate strongly to the idea that chemical knowledge can be expressed in 3 different forms. This idea, which has functioned as a heuristic for research in chemistry teaching, was presented 40 years ago by Alex Johnston and represented as a triangle. At these vertices of this triangle are located macroscopic aspects, the aspects referring to the world of particles that make up matter, and the symbolic and mathematical aspects of chemical knowledge. This heuristic about chemical knowledge can be exported and adapted to other natural and physical sciences as well. Currently, we are developing research to analyze semantic gravity in problem statements of chemistry problems from the Brazilian high school national exam. Partial data from this research was presented at the 2020 IOST Symposium, but we are still refining our translation device. As Carl Mayton points out, we need to adapt our devices to different research objectives, and in this case, we consider that the discourse in its written form does not coincide with oral discourse, particularly in its semantic profile. So, what are the main results found so far? What would I highlight among the main results obtained so far by our research is the research already conducted so far involved the study of semantic density and semantic gravity has indicated to us the importance of varying the strength of both in the construction of discourse, whether oral or written, for the process of instruction and communication of scientific knowledge. Secondly, I would also highlight the use of analogies and metaphors for the variation of epistemic semantic density. I would indicate that not all classroom discourse is amenable to analysis by the epistemic semantic dimension, and I'm not referring here to the so-called regulatory classroom discourse related to discipline and order, but to other aspects close to scientific knowledge involving values and ethical issues. I mean the axiological semantic dimension. Another aspect that our research confirmed is the need to construct or adapt the translation device for each knowledge practice in which we apply the study of semantic density and semantic gravity. Each discipline and each social practice that involves knowledge develops a singular language which should be readily captured by the translation devices. And what's coming next? I would say that the gaze we have developed for LCT and its semantic dimension from our experience leads us to think about its use in the configuration of more inclusive pedagogical practices in science, which manage to produce learning for all, regardless of issues of class, ethnicity, gender, age, sexual orientation. Therefore, we intend to use LCT as an inducer of transformative practice in science teaching that, by adjusting the variation in its semantic profiles, can subvert the production of educational inequalities in the interactions between teachers and students with scientific knowledge. Another aspect we aim to develop is the dialogue between the different dimensions of LCT with the semantic dimension in science education research, like specialization and semantics, autonomy and semantics. And what are the main challenges and implications of using the semantic dimension for science education? So, the study of the semantic dimension strongly involves the discourse linguistic analysis of practices involving knowledge. This is a great challenge for us who come from the natural sciences and have not mastered linguistic theories such as systemic functional linguistics. Secondly, in the investigation of semantic density, we rely on concepts such as technicality, grammatical metaphor, and lexical density that help us to understand how scientific language is constructed. As for semantic gravity, my understanding is that we are still lacking similar concepts to characterize the linguistic construction of context and abstraction in science teaching discourse. Another relevant question is how to incorporate the multimodality characteristic of science language and communication into translation devices. Some colleagues are trying to solve this challenge, and my personal opinion is that there should be more exchange among the authors of these devices towards a homogenization of the construction principles of the devices. I talked earlier about the necessary dialogue between the different dimensions of LCT with the semantic dimension. Another major challenge is how to implement pedagogical practices that, by varying degrees of semantic gravity and density, contribute to enhance learning in science and to address the reproduction of educational inequalities. Lastly, all of the papers mentioned here in this presentation and others can be obtained at this internet address. I would like to thank you for the opportunity to be here, communicate my work, and I hope that this presentation will motivate other colleagues interested in science education who are working with LCT to interact collaboratively with us. That's all, and thank you very much for your attention.
So this was the presentation of my colleague, Professor Bruno Ferreira dos Santos. I thank him for having pre-recorded it for us. They felt more comfortable to talk with you by pre-recording. I will now show to you the presentation of my other colleague, Professor Eduardo Mortimer. He also have pre-recorded and he's working, as you have saw, in collaboration with Professor Bruno, talking about science and this translations device in teaching science and searching for social justice. So let me share with you the presentation of Professor Eduardo Mortimer now. Just check if this is going with the sound.
Hello, everybody. It's a pleasure to take part in this LCT conference, and I would like to say thanks to the organizing committee, particularly to Professor Marcus Medeiros Pereira, for inviting me to participate in this debate. I'd like to start by saying that Bruno Santos was fundamental to introduce myself in the field of LCT. I received Bruno in UFMG, my university in Brazil, for a sabbatical year in 2017. From this collaboration emerged the 2019 paper Bruno already told you about. From this time, I began to discuss with my PhD and master students how to apply the LCT to their work. As a consequence, we have now 2 of those students presenting in the LCT Brazilian conference. Lucas Barreto is presenting some result of his PhD, which is about characterizing the semantic dimension of biochemistry professors teaching a basic biochemistry course. Jordana Bier is presenting her master thesis, which is about the dimension of specialization of the discourse of farm workers of an agroecological project. And Marina Valentim Barros, who is spending her sabbatical year with me and is presenting her work on the semantics dimension of LCT to analyzing quantum mechanics books. In this screen, you can see the article I'm going to present. We published this article as a group in the special issue of Research in Science Education, which was about the methodology of classroom discourse analysis in science education. The aim of this article is to compare 3 different translation devices. The first 2 translate devices are ways of systematically exploring the characteristics of the knowledge expressed in the classroom and how they vary, generating semantic waves. Neither of these two translate devices demonstrates how meaning are connected in the lesson and how the semantic density of a particular concept changes over time. In this sense, we explore how everyday words at times become loaded with technical meaning when other concepts are connected to them. To achieve that, we use a third device based on network science, an approach that analyzes and represents the systems of interactions of a wide range of physical and social phenomena. The participants in this study were the students and teacher of an environmental chemistry class of a chemistry undergraduate course at a public university in Brazil. The teacher was chosen from a video database of a professional development group of science teachers, in which we have a sample of videos from university professors from Brazilian universities, select based on an assessment questionnaire answered by their students. In this sense, the select professor was considered to be a good teacher by his students. We also select the episode of the lesson to be analyzed because of the subject the professor was teaching, which had many symbolic representations. We decide to analyze only a fragment of a lesson in which the teacher fully explained the phenomenon of luminescence. This fragment lasted 7 minutes and 45 seconds and was chosen based on the fact that it is a complete explanation and was independent from the previous and subsequent parts of the lesson. We opted for a small part of the lesson due to the methodological complexity of showing how 3 different devices work. The video files were used to transcribe the class for analysis using all the devices. The first device we used in our research was originally published by Santos and Mortimer 2019, and Bruno already told you about. It explores how the forms and organization of chemistry knowledge occur in instructional discourse. We used the 3 dimensions of chemistry knowledge to propose 4 different levels of semantic density, depending on the conceptual relationship that were established in the discourse. What this translation device provides in terms of the epistemic semantic density is the possibility of locating the discourse on a general level, which corresponds to a way of building knowledge in. Accordingly, at level 1 of semantic density, discourse is concerned with macroscopic entities and everyday knowledge. Each level adds complexity to the semantic density with the passage from the observable macroscopic words to the unobservable submicroscopic words, and then to the symbolic representation. In drawing semantic profile using this translation device, we assign the levels to the y-axis and time to the x-axis. The second device that we used is called the wording tool and was developed for the English language by Matthew and Dora. This device was meant to explore the complexity of meaning expressed by words and how this complexity is increased through their combination with other words. Thus, instead of basing the levels of semantic density on the general and invariable characteristics of a particular type of knowledge, this device resorts to the classes of words used in building the discourse. Matt Van Doren proposed a distinction between two types of word, technical and everyday. Defining the former are words belonging to a specialized domain of social practice that forms larger constellation of meanings for each word. Thus, they have greater epistemic semantic density than everyday words. These distinctions are further refined by developing subtypes and subtypes for each of these types, for a total of 8 subtypes. According to the authors, the tool focuses on content words such as nouns, verbs, adjectives, and adverbs, rather than grammatical words such as prepositions or conjunctions. Since we need a way to compare different translation devices, we propose a quantitative way of using their tool in which we count points for each content word within a clause based on the strengths of its semantic density. The stronger the epistemic semantic density, the more points are scored. The weaker the epistemic semantic density, the fewer points are scored. Here you have the wording tools with everydays and technical word divided in common and consolidate the everyday. And each of these are divided in other subtypes. And the technical are divided in compact and conglomerate. And the subtypes are elements or properties. In addition to the wording tool, the author proposed the wording grouping tool, which shows how some words can boost the epistemic semantic density of other wordings by adding additional meaning to them. For instance, in excited electrons, the word excited categorizes electrons implicitly showing that there are other types of electrons, which puts the word electrons into a larger constellation of meanings. Since we still lack an established device to analyze semantic density in images and their elements, we made an approximation by scoring a pictorial element based on its name. Therefore, if the professor drew an atom in the blackboard, every time he referred to that representation as this while pointing to it, we score this as a proxy for atom. With all these considerations in mind, the points according to table 2 and 3 were scored for each content word. Since we were scoring groups as they occurred in clauses and not individual words, we added all wording and grouping score for each unit of meaning. In our analysis, we divided the class into units of meaning using the transcript of the class video. These units of meanings are composed of independent clauses composed of at least a subject and a verb, which might be followed by one or more subordinate clauses. Each unit of meanings score was divided by the number of content words it contained. Proxy words only counted as individual words, even if they refer to more than. Here we have the table 3 with the wording group tool. And we have 3 types: located, categorized, embedded. The third device we used was developed based on the idea of constellation of meanings. Thus, while the first two devices highlight the condensation of meaning, the third device emphasizes the product of these processes by focusing on its constellation of meanings and showing how each meaning or concept relate to the others. To develop this device, we proposed applying the techniques developed in the field of network science, which is a growing field of research based on mathematical graph theory and provides quantitative methods to investigate complex systems as networks. A network is composed of nodes and edges. Nodes are usually represented by spheres and are the basic units of a network. In our network, they represent concepts that were explicitly taught in the classroom or drawn on the blackboard. Edges are the connection between nodes and in our network show the relation of meanings. To create our constellation of meanings, we had to build a matrix that served as the basis to build our network. This matrix marks the presence or absence of a connection between any two nodes. We developed this matrix by analyzing the relation between concepts in the transcripts and create a table in which we set the orange nodes of edge or source and the target nodes of the edge. Once the complete matrix was generated, our data were imported into the open source software Gephi to visualize and analyze the constellation of the meanings network. We evaluate the division of the network into modules or communities using the Louvain modularity method provided by Gephi. We were able to identify communities of nodes that were more connected to each other than
Okay, sorry, I felt again. I will try to put it once more.
to the network. Now we are going to present some of the results. We observed that the teacher conducted his talk in a movement that went from a highly dense semantic discourse in the beginning of this to a semantic wave in the end. In the beginning, the teacher talked about highly structured and semantically dense concepts such as electronic excitation and molecular orbital theory. While in teaching these concepts, the classroom stayed at a flat line on the symbolic semantic density level. Subsequently, the teacher began the process of unpacking the knowledge by illustrating meanings and connect them to the concepts from daily life. He introduced where these phenomena might be observed in the classroom, such as in the fluorescent lamp and the light switch, and then elaborated these concepts. Although he associated scientific and everyday concepts with the phenomena, he packed the knowledge by providing insights to how the chemist components of the lamp produce light using molecular orbital theory at the submicroscopic level. Interesting, he never fully returned to the symbolic level because he used the concept he introduced at this level to explain what happens at the microscopic and macroscopic levels. While the professor made connection between the phenomena and the molecular orbital theory explained at the beginning of the class, we observed another flat line at approximately 23 minutes. Although our analysis using the translation device proposed by Santos and Mortimer showed two regions that could be considered a semantic level flat line, however, we decided to analyze them better. Were these regions truly semantic flat lines? Was there any variation in this level that the device was unable to identify? To answer this question, we used the wording tool device proposed by Matthew and Doran. Initially, we decided to analyze only the first and large region that could be a semantic flat line. We observed that although the teacher constantly used technical words throughout the explanation, high amplitudes variation could be detected when using this adapted device. This unexpected behavior led us to perform a locally estimated scatter plot smoothing, that's called LOES, to determine whether we could examine an overall pattern of semantic density behavior. Here is the loss curve that we determine. Interesting, by using loss strategy, we could observe a slight increase in the overall semantic density at the end. This increase was leveraged by the use of words with high semantic density, such as sigma bonding orbital and sigma anti-bonding orbital. This increase at the end of this part of the text could mean that the flat line observed using the first device was not actually a flat line, and that the first device was unable to differentiate the semantic density variation observed by the second device. Now we are going to show what we obtain with the third device. Our analysis revealed on a small interconnected network consisting of 77 nodes. The nodes which the highest number of connections degree were lump, which 37, followed by energy diagram representation with 27. In addition, we ranked the node size by its betweenness centrality, which represents the number of times a node lies on the shortest path between other nodes. For our network, energy diagram representation has the highest centrality, followed by lump with the second highest centrality. We were also able to find two large and two small communities using the low-Venn modularity methods, with a parameter resolution of 2.0. The first large community represents the first half of the class, in which the teacher explains the process of electronic excitation and relaxation using an energy diagram representation of the molecular or orbital model. The second large community represents the second half of our data, where the teachers connects the first half with a concrete example of the lamp, an object presents in the classroom. These two larger communities belong to the world of objects and events, the lamp, and the world of theories and model, energy diagram representation, respectively, whose interrelation is, according to Tiberghien, one of the biggest problems in learning physics. This shows that through the integration of these two worlds, the teacher was able to reconstruct the common world represented by the word lamp in a dense but still less complex worlds, where the connection between these two worlds was made by concepts such as light, emit, luminescence, phosphorescence, radiation that are just in the limits between the two larger communities. It's interesting that at the border of these two larger communities is the phenomenon of luminescence and these two corresponding phenomena, fluorescence and phosphorescence, which are at the core of the teacher explanation. Summarizing, this article articulates two different translation devices present in the literature and shows the affordance and limitation of both in describing a teacher performing semantic waves. Nevertheless, while the first and second devices allow us to trace the change degree of complexity expressed by building a semantic profile, they only reveal successive states of the epistemic semantic density through time and not how knowledge is being built into constellation. Nevertheless, we reveal a new complexity around the integration of meanings by visually showing the constellation of meanings through a new device based on network science. We have shown that a common word lamp becomes the dense word in the teacher explanation because it is a word that can relate to all the concepts, belong to all the levels of the first translation device, and all the technical and everyday words belong to the second translation device. Thank you very much.
So thank you, Professor Eduardo Mortimer. These were the two pre-recorded presentation that we have prepared for LCT 3.5. Bruno and Eduardo are here with us. So if you want to talk, to have some questions to them, I can translate it and you can ask something if you want. If no questions are here, I can talk a little bit about my own studies here in Brazil. We have LCT is that unite us, but my research object is related to music and to music teaching. And I'm using also the semantics dimension, but also the specialization dimension. I participate in the LCT Hub with Professor Lee Husniak, and it's really inspiring for me to work with my teacher training students in meaning, in music, to make the musical knowledge and the teacher knowledge, the pedagogical reasoning visible to them. So we are using the semantic dimension in our internship activities, so we can analyze videos in this time of pandemic where we are not going to schools in person. So we can analyze some videos of music teachers in Brazilian schools before the pandemic period. And then we can see the profiles of this teaching. And these are being very, very helpful to them to think about the choice. The project that Professor Lee conducts in South Africa is Teacher Choices in Action. And I brought it to Brazil to work with my students to make this knowledge, these choices of the teacher visible to them. Because we have some issues in music teaching that all of our students are already teachers. They do not need to go to university to become music teachers in a real world. So if he learns to play his instrument, if he learns 3 notes or 3 chords in a guitar, he can teach it to his friend. So they go to the university thinking that they already can do it. So they do not pay attention, they do not legitimize courses on music education. They prefer to give their attention to the specific content in music. That's the why they went to the university, to continue learning to play and to play better, because there is a belief in our music field that the teacher is who can play. So if he can play his or her instrument, he is already a good teacher. So when they go to the university, we face a lot of problems to try to make them understand that it's not like this. There's a lot of complexity in teaching. Teachers need to have a lot of decisions in the ways of talking to students, in the ways that he can build cumulative knowledge, musical knowledge. So it's a great question to work with them in music education courses. And LCT is helping me to make it visible to them. So I showed today in our regional sections here in Brazil, some of the texts that my students have written when they saw a video for a first time. And it was just something like that. Oh, that was a very interesting class. The teacher had the attention of her students. And so she is a very good teacher. So there's no pedagogic reasoning in that. And then when we build a translation device to think about this musical class, they could see that it was with the whole class was with a very stronger semantic gravity. The students in this video has just experienced some musical situations, but they didn't talk about that. They didn't learn specialized language in music to think about what they were doing. So to repeat what the teacher was doing, everyone can do it. But if you are at a music school, or if you want to learn music in school, you need to be inserted in a common language, in a specialized language in music. So we need some technical terms. We need to think about them. We need to use them in our classes. And then watching another videos where they can see teacher doing this. Yes, a lot of experience, because in music, we need to learn the musical concepts, and we learn music by doing music. It's one of the the most important principles in teaching music and in learning music. They have to experience a lot, but they have to talk about it in a meaningful way, using some specialized language to think, to create, to involve more deeply in a music practice. So these semantic profiles are helping us to make this knowledge visible to our students. And I thank a lot Professor Lee Husniak for receiving me in her hub. And I'm learning a lot to use, not just to use LCT concepts, but to have interesting activities with my students to make this pedagogic reasoning happen in the becoming of a teacher. And Judy is saying here that music is such an interesting field for LCT concepts. Yes, and it's very, in some way, it's really difficult to use it. We have to adapt a lot to our field of practice, because we can have music as a horizontal discourse, because we have a lot of practices, different practices, a lot of languages as samba, classical music and popular music and jazz, that are different languages. And we have also a hierarchical discourse with a strong grammar, because music theory is a hierarchical discourse with a strong grammar, and different practices uses this theory in its own way. And it's really difficult, especially here in Brazil. Our music courses teaches just Western music, classical music. And it's very interesting, because when we receive international students in our courses, they want to learn Brazilian music, but they just have here more of Chopin, Bach, Beethoven, and where else. We have not our music, and our students do not study the music of their country. So yes, that's a really interesting field for having LCT, and LCT can help us a lot to change the situation of this field.
Just to make a connection, just because this is one of the things I love doing at conferences, there's a PhD student in Florida who's looking at still drumming in Trinidad and Tobago, like the masters of still drumming as a field, which is like so fascinating, because you've got that legitimation of a local cultural artifacts that's become technicalized very recently. So I'll grab his name, and so if it's somebody who you might have productive discussions with, you can get in contact. But yeah, he's part of LCT North America. So if you ever want to join us, give me a yell.
Yes, please. I will put here my email, and we can keep talking about this, because this is very interesting in music, as you said. I will put here my email, and we can keep talking.
That would be great.
It's 3 o'clock now, so we have to go to the other session. I thank you all for the attention. I thank Professor Eduardo, Professor Bruno for sharing their experience in science teaching with us. And I thank for the last 10 minutes where I can talk about using LCT in music. That's my own work here in Brazil. Thank you a lot. So let's go to another session. Brazil is open to receive you here and to talk a lot about our LCT concepts. Thank you very much.